Okay, so welcome to this next video on electrically triggered calcium oscillations, and where we're specifically looking at the sino-atrial node. Okay, so we've seen how the oscillatory behavior of the action potential in the sino-atrial node tissue leads to an oscillatory concentration of calcium in the sino-atrial node tissue. Now, the sino-atrial node tissue, its role is to create the action potential, is to create the pace for the heart, basically, the heartbeat. But it is a contractile piece of cardiac muscle, basically. So, the function of this oscillatory calcium level is to cause contraction in the sino-atrial node muscle cell. However, these calcium oscillations triggered by these T-type calcium channels are pathetic, basically. They are not enough to actually trigger contraction on their own. So basically, what these need to have happen is they need to be amplified, basically. And that's what happens. So when the calcium goes up, what it does is it triggers calcium-induced calcium release. So what will happen is it will go to the sarcoplasmic reticulum in this cardiomyocyte, and it will activate the ryanodine receptor 2, which I'll draw like this. So the ryanodine receptor 2 is a massive great receptor. It's made up of 4 subunits, all of which are encoded by the same gene, the ryanodine receptor 2 gene. So this is the ryanodine receptor 2 gene, type 2 ryanodine receptor. Ryanodine receptor. Okay, and basically each one of these proteins that makes up a quarter of the type 2 ryanodine receptor, it has around 5,000 amino acids in, basically, so it's a massive great protein. Okay, so basically what happens is that when calcium comes along, because it's come up by entry in the through the T-type voltage-gated calcium channels, calcium is going to bind to calcium binding sites on each one of these 4 subunits that makes up the type 2 ryanodine receptor. And when 4 calcium molecules overall bind to this type 2 ryanodine receptor, it's going to cause it to open. And then what will happen is that calcium will be released from the sarcoplasmic reticulum, and then that will amplify hugely these calcium oscillations. So now what you will see is, you'll see a calcium oscillation that's potentially like this. You'll see huge great calcium oscillations because of the amplification through the type 2 ryanodine receptor releasing intracellular stores. And these larger calcium oscillations, those will trigger muscle contraction in the cardiomyocyte.